Welcome to the Retro 21 Studios podcast. I'm your host, M Squared. Hi, Ian. Hi, Mo. How are you today?
Hey, I'm doing good.
Awesome. Really excited about this podcast and just to hear what Adaviv is up to these days. Ian, you and I spoke last week and we talked about ag tech and some of the cool applications of artificial intelligence. You guys have some papers out there, just a lot of exciting stuff. So let me turn it over to you for quick introductions, tell a little bit about yourselves, and we could move on from there.
Sure, sounds great. Thank you, and thanks for having us on. We're excited to tell you about what we're doing and how we view like the broader agriculture technology picture and how we think, for example, AI is going to change the landscape, hopefully for the better, and help farms be more sustainable, more productive. So that's definitely our end goal. We're an ag tech company out of Boston, spun off MIT a few years ago. Myself and Mo are two of the three co-founders. And we work with what they call controlled environment agriculture. So these are farms that are various levels of control. It can be from very low-tech greenhouses with hoop houses and plastic coverings to very high-tech Dutch-style glass houses and indoor farms, vertical farms. Any farming where you can, as the name says, control the environment to some degree. That gives farmers, it gives us as a technology provider the ability to control more inputs more precisely and have better outputs with the crops. And that's what we help them do. We use a set of AI technologies and a software platform that we've built called Lean Cultivation. And we help, as the name suggests, help those farm operators be leaner in their cultivation practices and operations. And that falls into two main categories. One is inputs and labor. So it's a very complex thing. It's a very complex manufacturing system in these farms. It's biological growing things. So it's very hard to manage the inputs and to manage costs and to manage labor. It's one of agriculture's biggest pain points. And we help them understand how to allocate the labor, how to allocate resources effectively, and reduce their cost per pound of production. That's our end goal, help growers reduce cost per pound. Awesome. The other second area, the last thing that I'll say is we help them understand their plants better. So use computer vision, AI tools that we're developing to help understand when the plants are stressed and help them respond very rapidly to reduce yield losses to pest disease and stresses, which can come from equipment failure in the environment as well. So that's what we do, help growers optimize cost per pound with lean cultivation and AI. And my name is Ian, and I'm the CEO and co-founder of Adaviv, and this is one of my co-founders, Mo. I'm a biologist by background. I'll let Mo introduce himself.
Yeah, I studied physics, but I ended up doing AI after graduating, and I moved to Boston. I studied in Vancouver and moved to Boston in 2015. And that's where I met Ian at a lab at MIT. And the lab was very multidisciplinary. Ian was coming from the biology, environmental science background. I was coming with my physics degree. And I think it created this incubation kind of like environment for us to discuss and come up with this idea of trying to use our expertise to help agriculture.
I'm going to go back to the basics. Adaviv, how did you guys come up with the name?
Yeah, that's a good question, and it has a story there too. When we met back at MIT, we actually, as Mo was saying, we were working on various projects in the lab, a lot around like how AI can optimize networks, can optimize the dynamics of different systems in cities and energy systems. And we caught the entrepreneur bug. We wanted to leverage all those resources at MIT. And we actually started working on a wind turbine project, thinking we can use AI to optimize the energy capture capabilities of wind turbines. And as a biologist, we were thinking of a name to call the project. And as a biologist, I'm always naming things with Latin roots, right? That's what you're taught to do. So Ada means adaptable and Viv means life. So it was around adaptable life, adapting systems to be more powerful, to be more efficient. Very long story short, we didn't end up pursuing the wind turbine project, and we turned to more of what we knew, which is me, plants, biology, agriculture, Moe, software engineering, and machine learning, and applying it to what we do now with agriculture. But long story short, adaptable life, the name stuck. It fit for what we do now, and so we kept it.
And are you guys still connected with MIT?
Yeah, I would say so. We still have our advisors and friends from MIT, and being based in Somerville, Massachusetts, it's like a short biking distance, like 10 minutes walk to MIT. Sometimes we meet there, and we are also still part of some programs at MIT. I think MIT has this, and through the industrial liaison program, I think we also participate in some kind of like corporate relation meetings that they organize from time to time.
Yeah, coincidentally, we were just featured on the landing page of the Startup Exchange website of MIT, and so if people want to find out more about what we do in that program, they can check it out there.
By default, you guys are doing groundbreaking research in ag tech, and obviously that would extend to academia as well as corporate America. You mentioned optimization of crops, higher yields, and talk a little bit about how that translates to lower costs for consumers.
Yeah, that's a good downstream connection. We would hope that as we help make growers more efficient and increase their margins, that gets passed on to the end consumer as well. And that's a big topic to explore on its own, but farming is a relatively low margin industry, and a lot of the profits that are captured at the end of the supply chain are captured by the retailers. So our focus is to help those farmers at the upstream make more money, because even if you're buying like high priced organic or you're buying commodity priced corn, the farmers are often making the same amount. It's because their margins are thin and their production costs are very high. Like labor is like one of their highest costs. Anywhere 30 up to 60% of the production costs can be labor in these farms. And then inputs and energy are high costs as well. So we're helping them through dynamic planning and advanced planning solutions, which AI can really help with, allocate their resources better, increase productivity by democratizing data in the growers working in the field so that everybody can be a part of identifying issues in the crop, communicating which tasks need to be done, where they are in different tasks, and bringing that visibility up to the managers. By doing so, we create these really efficient standard operating procedures where everybody can really operate at the highest, same level. So the end result is productivity increases, and the farms can do more with less inputs and less labor. So that's one big area that we help in. And I know that kind of didn't touch on the consumer piece, but again, our focus is really on the upstream, helping the farmers be more profitable, and hopefully that's passed down into the end consumer as well.
Yeah, that was helpful. You talked about the democratization of data, this standardized processes and information. When you think of agriculture as old as people, right? But there's a lot of knowledge gained over the years. And in our conversation last week, I think we talked about how that data is somewhat tribal right now and it's inconsistent. And so your goal is to bring some level of consistency to that for the greater benefit.
Yeah, 100%. I'll maybe let Mo touch on how that converges with data and AI and software, but that's both an opportunity and a challenge for us, is that a lot of that knowledge of how to grow crops well is in maybe one person's head in that farm. And now these growers, these managers have to manage multiple people, multiple farms. So how do you spread that knowledge out? I think what we're building is one tool for them to do that, but maybe you can talk about how that kind of growing knowledge translates into.
Yeah, I think it's sometimes going into the farms and seeing that still some farms rely on very informal ways of collecting data, even though farming originally, I think, created some original statistics was inspired based on farming, but I think there is over time this gap got widened with technology use in farming. There is really high tech like use of the technology in the lab setting, in an R&D setting in farming, big corporations that do phenotyping. But in actual practice of farming, I think there is still a lot of gap in how certain cultivars behave, different environments, even with labor, like tasks like de-leafing across different type of strains. The farmers is still kind of a struggle with really understanding how different, because of lack of data.
Mm-hmm.
They have the knowledge, but because of lack of data, kind of variability management becomes difficult, and variability management is the challenge of farming, how from one cultivar to another cultivar. Labor, the speed in executing tasks vary, how the output of like the response of efficacy of certain treatment differs from one cultivar to cultivar. So what we do, we try to democratize that standardized like data collection through the simple kind of like software, and also I think more advanced version of it is our crop scanning system, which we call ScoutPod. But even with the software, you can still benefit from closing the gap on the data side, so that you enable all these kind of analytics that help with the variability management.
Mo, what was the name of that application again that scans the crops?
We call it a ScoutPod. So it's basically a machine that we bring into the farm. We have a ground-based version of it, which we call Mantis. And we also have an aerial like cable cam system that we have kind of like we have a pending patent application for it. These two different solutions are called Adaviv ScoutPods, fall under that category and help with scanning crop, identifying sources of like pests.
So based on that variability that you described earlier, so do you, in order to gather the baseline, I guess it's baseline data, correct me if I'm wrong, but in order to do that, do you have to have some sort of clinical type setting where you have crops or environments that are fairly controlled, right? You have certain constraints where you could get the data, you're comparing apples to apples, and then through the application of AI, you extend from that. Am I in the right path there?
Yeah, so I would say actually we try to do the heavy lifting under the hood and make it easier for farmers so that they can treat their farm like an actual like real world lab. So they don't have to do those type of isolated experiments to learn from their crops. So with every data point that we collect, we try to do those type of like correlations based on we create this like geospatial data we call load map, which specify in which location you have what cultivar under cultivation in your farm. So that data helps us establish correlations between, okay, in this location in the farm, these issues. Therefore, we see this pattern correlating sensitivity of this cultivar with this type of pest pressure. So I think we do that heavy lifting.
We're working with and establishing some university partnerships now, and so it's a balance, right? We try to create a return on investment for our grower partners as fast as we can within the first couple of weeks of working together. That's by capturing different efficiencies, just creating better visibility over people and plants, helping them better dynamically allocate labor and resources. But when it comes to understanding like how do we detect a pathogen like botrytis, which is one of the biggest, most common causes of crop loss in things like tomatoes and flowers and cannabis? How can we detect that early before the human eye can see it? That's where like a controlled experiment will be really valuable. And we're working with like university partners to set up those more controlled experiments where we can combine field data with lab data to understand like what spectral signals we can derive from the images to be able to detect the risk, those pathogens, but the risk of it too, what conditions create that. So it's a combination of both, but we do a lot of this kind of real world kind of experimentation on the go as well.
Ian, is there any predictive capabilities there? So I'm thinking in terms of, so I'm a big fan of organic foods and products. However, there is a GMO market out there. And so one of the areas that I would imagine from a GMO perspective would be, how do we craft a plant that's resistant to the powdery mildew or some other pathogen? So any links there, or what's your perspective on that?
Yeah, good question. I think two things. Like, one, this idea of trait discovery is really a huge area of research, and AI on the modeling side and genetics side, combination of protein work, but also CRISPR and DNA research. This area, this biologicals and trait prediction or type prediction, is a huge area.